In any event, this is part one of a talk on zircon for those of you who don't know what you've gotten into. And the subtitle is An Ancient Gem, but I came up with about 2 or 3 others. The Schizophrenic Gem, the Mystery Gem, because it really fits all of those. I mean, most people have heard of zircon, but they don't really know anything about it, as I will show you in the next few minutes. And this is going to be sort of a strange talk because for the most part, even though zircon, as I said, is schizophrenic and has 2 very important roles to play, one of which being a gemstone, the other is scientifically, and I'm going to leave all the scientific part out for part 2 as best I can and just concentrate on the gem side of it in this talk. All right, so first of all, what is zircon? And that sounds like a pretty straightforward kind of question, but it's not. And so I've been talking about zircon as a gemstone, and it's a mineral, zirconium silicate. But as I said, it's extremely important both commercially and scientifically, even though I'm not going to talk about it. But zircon, as part of its schizophrenia, is also the name of a group of minerals. And so it has 2 different uses depending on what you're talking about. And the group of minerals are all silicates, pretty much, with a general formula that looks like the formula for zircon itself, where you have cerium and thorium and hafnium and uranium as possibilities. And they're all isostructural, which means that they're all tetragonal with 4-fold symmetry. And surprisingly, the group also includes yttrium phosphate and tantalum niobium borate solid solution series. And there's a couple of other even stranger ones that are all isostructural minerals in the zircon group. But the good news for us is that zircon as the silicate is the only gemstone in that group. Now, on top of that, most people confuse zircon with cubic zirconia, which is in fact a zirconium compound, ZrO2, but it's not at all related to zircon. And because cubic zirconia is primarily a synthetic material, that's given zircon a bad name. And I'm not going to talk about the history of cubic zirconia. As usual, I've got all sorts of extraneous details on my slides that you can read about at your leisure. So I'm going to step back now and review something that I talked about in the introduction to the barrel talk, and that is how silicates are formed. And so we start out with what's called the Bowen reaction series, where we have 4 major mineral groups that come out of the lower mantle as magma. And as that magma cools, various kinds of silicates are somewhat transformed and precipitate as the temperature gets lower and lower. And then at the very bottom, you see what are called the felsic silicates, and they solidify last. And among the felsic rocks is granite, and it's composed of felsic minerals. And one of those felsic minerals is zircon. Now, zirconium is a very rare element, very, very low abundance in the Earth's crust. And it turns out the vast majority of it is spread throughout the crust as what's called an accessory mineral in almost all igneous rocks all over the world. And because zircon is extremely durable, because it's heat resistant and chemically inert, it ends up in other kinds of rocks, metamorphic rocks and sedimentary rocks as well. And in fact, the major commercial source of zirconium, which is a very important element in all sorts of fields, comes from sedimentary sand deposits, primarily in Australia and also in South Africa. And so to sort of complete the picture that I just presented, if you look on the lower left, those little tiny crystals are what zircon looks like in granite. And the size of those crystals is about the width of a human hair. And on the right side, you can see a picture of the world's largest zirconium mine. And it's called the Jacinth Ambrosia mine, and it's near Perth in Western Australia. And you get some idea of the size by looking at the huge pieces of equipment that are dwarfed in that picture. And I've highlighted the word jacinth as for a reason that you'll see in a little bit. So as I said, zircon is sort of schizophrenic because gemstones are not possibly those little tiny crystals, and gemstones of zircon are formed in an entirely different way. They're formed very much like beryl is formed in pegmatites. And so to review what pegmatite formation is like, you got hot magma coming up out of the lower mantle. It cracks the surrounding cold rock when it hits it. It's under enormous pressure, so it flows into those cracks. And eventually, when that magma cools, it forms seams that are called pegmatites. Now, that magma contains fluid, volatiles. And since they're under incredible pressure, even though most of it is water, it stays as a liquid, and it sort of forms little pockets in the pegmatite as the pegmatite cools. And what you can see on the right is that you start getting layers of silicates cooling around the outside of those pockets in layers, and more concentrated at the center are ions of rare elements in that fluid. And then as that fluid cools, those rare elements are forced to combine to form rare minerals. And usually, because that cooling is slow, you end up with large crystals, in the sense of large being big enough to cut gems from them. Now, in the case of zircon, it's not quite that simple. And so I'm going to talk about petrology and geochemistry, where I'm using an element classification out of petrology, which is the study of rock formation. And you can see that we've got three different general groups of elements, where the ones in turquoise are the mantle rock forming elements. Those are the ones that are the mafic rocks. And then we have these other two groups, the HFSEs and the LILEs. And I'm not going to talk about the LILEs, but they're basically elements that have very large ions. And then I'm going to concentrate on the HFSEs, because both of these groups of elements are unusual in either size or charge, so they don't fit into common minerals. And so basically what we have is zircon being a high field strength element, and it's called that because its cation has a +4 charge. And so it can't replace the other cations in common minerals, like felsic minerals like sodium and magnesium. You couldn't get a charge balance. And so it gets more and more concentrated as all of these other rare minerals start precipitating out, and it becomes concentrated in the last of the fluid in the center of the pockets. Well, it turns out that the other elements in the zircon group, hafnium, thorium, and uranium in particular, are also HFSEs, and they also have these high charge cations. And so they become concentrated along with zirconium in those same fluids. And when zircon sulfate or silicate crystallizes out, it brings down hafnium and uranium and thorium with it. And zircon always contains hafnium in fairly large quantities, as well as traces of uranium and thorium. And that's very, very, very important scientifically, but I'm not going to talk about that this time. Now, the other elements that are in this HFSE category are the rare earth elements, the lanthanides, from lanthanum to lutetium, all 14 of them. And so they're in that same pot along with zirconium and silicate. And so zircons always contain traces of all of these other rare earth elements as well. And that's also extremely important scientifically. Again, I'm not going to talk about that aspect, but as you'll see later, they're also key to certain gem properties of zircon cut stones. So I'm going to change tacks again and show you where someone like me who has an interest in etymology, the study of where words come from, and history, what can happen to you when you get on the trail of something like the name zircon. And so, as I mentioned in the title, zircon is a very ancient gem, and it was found in pre-dynastic Egyptian tombs. That means before the pharaohs, and also in Assyrian tombs. And so zircon's use as a gemstone is at least 4,500 years old, and probably a lot older than that. It's also mentioned in the earliest Sanskrit texts from about 2000 BC, and in Hindu mythology, it's the leaves of the sacred kalpa tree. And I'm not going to go into that, but that again is a very interesting side trip that I took once upon a time. Where I am going to concentrate is the fact that it's also described in the Old Testament in a version that was probably written before the 12th century BC. And the way it's described is as one of the 12 gems on the breastplate, and there's a replica down below of the ceremonial robe of Aaron, who was the first high priest of the Jews and the older brother of Moses, and a key figure along with Moses in the Exodus. And I want to concentrate on that yellow rectangle in the third row down on the right, in particular. So at the time of all of this happening, the gems in the breastplate were unknown. People didn't know what they were. And so their identities have been surmised from their descriptions, which were usually of colors or even of places where they came from. And what those gems are is, for whatever reasons, of great importance to biblical scholars and is still discussed. But zircon is assumed to be one of those gems, in particular that yellow one. And in Hebrew in the Old Testament, it's called leshem. And it's mentioned in lots of places in the Old Testament, and I just gave one. And so the next time a name for what's assumed to be zircon shows up is in the translation into the Greek Septuagint version in about 300 BC, and that's now Ligurios. Well, so that's been sitting there for a few hundred years, and then Josephus decided to name the breastplate gems, and so he's got this whole list, and of course he didn't do it in English, but you can see that everything has a name that we can sort of recognize as a modern gem name, except for that Liguri, right? So nobody knows what that is. And it stayed that way for another 400 years. Pliny the Elder in about 40 AD called it hyacinthus, but that was probably wrong because hyacinthos in Greek means blue. And at that time, zircons were very, very unlikely to be blue. And you'll see why in a little bit. So that seems to be a false name. And then later on, Pliny wrote a 37-volume of natural history, and he described a mineral that was honey-colored as melachrysos. All right, and so that's another possibility for what zircon is. And then 500 years later, the father of mineralogy decides to call it jacinth. Remember the name of the mine? The jacinth mine. But at the time, jacinth meant the color violet or purple. And so again, that's unlikely to be our zircon. And then by 1737, in the English translation of the Old Testament, Whiston decided he still didn't know what Liguri was in spite of all these attempts, and he just called it Liguri. He never gave it a name. And then finally, in the middle of the 1700s, a Swedish mineralogist called it jargon, and sometimes it was called jargoon, both probably from a transliteration of Zargun from the Arabic into Old French. And so we got two more names. And then a few decades later, a French geologist called it hyacinthe. We're back to that again. Hyacinthos from before. And then eventually in 1783, a German geologist finally called it zircon. And from the Arabic, zargun means